Okay, today we're going to do an introduction to radicals and I, which actually stands for an imaginary number. In the realm of numbers, you've got real and imaginary, and imaginary will turn into complex numbers, which, even though it says imaginary, it is a real thing. Okay, and imaginary numbers are used in present day some careers. Okay, so it's not completely useless. People who deal with electricity, if you know anyone who is an electrician or electrical engineer, they actually have used I in their work. Okay, in the math that they do. So that's just it's just because it has the term imaginary, it's just a group of numbers. Okay, it's a group of complex numbers. So we're going to review how to simplify radicals. Y'all have learned that before, so that is not new. Imaginary will be new, but it's not a hard concept. Okay. So if you remember, let's say just something like this. Okay. We know that to be the square root of 4, right? Well, how do you know it's a square root? Well, we just know that this is a square root, okay? Right now, all we're looking at in this lesson is square root, but we will eventually get to a chapter where you have nth roots. So cube root, fourth root, fifth root, you could do, I mean, we're not going to do it, but you could do a 100th root. You can just have any root, okay? So this symbol is called your radical. Now with the square root, we don't have a number written, but in nth root, we do. And so if I had to write it, even though it's understood, that 2 for square root is called your index. But again, in this chapter, we're just going to do square root. Okay, the number under the radical is radicand. Okay, and I'm just doing this for the vocabulary. Okay, typically I say the number underneath the radical. You need to know what the radical is. Okay, radicand is the number underneath the radical. All right. So what we're going to do, we are always going to check for perfect squares. Always do that first. If you don't recognize them, most of y'all know the smaller ones, but you don't always recognize the larger ones. Make sure you check for that. It will make it a whole lot easier on you. Okay, so I'm going to show you how to check for that in the calculator, and then we're going to do our prime factorization. Okay, so factor tree, which hopefully y'all remember once I start doing that. Okay, and then what we're going to do is we're going to group our numbers. It's a square root, so you need to have a pair of 2. So it says it takes 2 of the same prime factor to write one prime factor on the outside of the radical. So I'm going to circle and box when I do my prime factor tree. So those of you who are visual, you can kind of see what happens. Okay. And then anything that's not paired, what's left over, stays underneath the radical. Okay. And then when it comes down to it, if you have a number in front of the radical, like a coefficient, then you would multiply that by the factor you take out. Okay. I'm going to get my calculator real quick, and then I'll show you how to check perfect squares. So if you look on your calculator, your radical button is right above the 7. Okay, that's all you need to know for this chapter. Okay, so if I'm looking at example 1, it says simplify completely, square root of 176. So I'm going to hit that square root button, type my 176. If it gives me a decimal, it's not a perfect square. If it gives me a whole number, it's a perfect square. Okay, so if it's not a perfect square, I need to take that 176, the radicand, and I need to split it. Okay, I need to do the prime factor tree. Now, I like personally to start by dividing by 2, 3, or if it's necessary, 5. Okay, sometimes I can do something other than that, but if you start with 2, it keeps the factor tree nice and clean. Okay, so if you take 176 and divide it by 2, then that's going to leave me with 88. Okay, so it will split between 2 and 88. Then I'm going to take 88 and I can divide that by 2, and that will leave me with 44. Then I can take 44, split that into 2 and 22. Y'all remember doing this? You should have done this in geometry too, because I know y'all did radicals in geometry. And then 22 splits 2 and 11. Okay, so what we're gonna do is we're gonna take groups of 2. So I have 2 2s that I'm gonna pair together. And then I have another set of 2 2s that I'm gonna pair together. And that 11, I'm gonna box because it's left unpaired. Okay. Now, it said it takes 2 of the same prime factor to write one of those on the outside of the radical. So all that means is this set of 2s, I only bring out 1 2. Because what's the square root of 4? 2, not 4, right? So with the square root of 4, that's 2 and 2. I make a pair and it equals 2. So the same thing is happening here. One pair, I write one number for. So then this set, I'm going to multiply, and then I've got the square root of 11 stays underneath the radical. Okay, so when I simplify radicals, whatever I circle comes outside the radical, and whatever I box stays under the radical. Okay, if you're visual, that's what I'm doing. Okay, so then I'm going to multiply. 2 times 2 gives me 4. 4 square root of 11 would be my answer. Okay, for those of you who want to make sure that you're doing it good and doing it right, you can check the value of your original and your answer. Okay, so I've already checked what the square root of 176 is, and it's 13 point blah blah blah. Okay, so if I type 4 square root of 11, and now if I simplified that correctly, then it should give me the same value, which it does. So I know I'm good. Okay, so if you are someone who wants to check your answers and start off strong the second 6 weeks, I would make sure you check that. Okay. Now the next one, 2 square root of 12, is square root of 12 a perfect square? No. So I need to take 12 and I need to do the prime factor tree. So that's going to split into 2 and 6, and 6 can split into 2 and 3. I've got a pair of 2s with a 3 left over. Okay. Now the 2 that I have with my problem, I already bring that down. Okay, that is a common mistake of not bringing that down, and that will cause you to lose points. Okay, then I take the 2 from my prime factor tree, and my 3 is left under the radical. Okay, so my final answer should be what? 4 square root of 3. Okay, and then if I wanted to, I could type 2 square root of 12. I get 6.93 rounded. And then I've got 4 square root of 3, which gives me the exact same value. Okay, so I'm good. All right, questions on this? Make sure you're boxing and highlighting your answers so I can sift through your work easier. Okay. All right, negative square root of 20. All right, is 20 a perfect square? No. No. So I'm going to take 20 and I'm going to split it. That can split into 2 and 10. And 10 can split 2 and 5. So I have a pair of 2s with a 5 left over. So what am I going to write in this first step? Negative 2 square root of 5. We good with simplifying? Do y'all remember how to do all that? Okay. So, imaginary numbers. Okay. If I take the square root of a negative, up until this point, you couldn't do it. Okay. Now, the square root of a negative 1 is your definition for an imaginary number. Okay. So, I equals the square root of negative 1. That's all there is. Okay. So, if you have a negative under the radical, you pull out an I for imaginary. Other than that, you move on like everything we just did. Okay. So, if I have the square root of negative 5, that's the same as the square root of negative 1 times the square root of a 5. All that happened is I split the negative 1 and the 5. Okay. Now I'm only going to do that for like these first 3 examples, and after that, hopefully you know just the moment you see a negative, you pull out an I. We don't have to write this. Okay. So if I'm looking at the square root of negative 1, by definition, that's I. And then I'm going to look at the square root of 5. Can I simplify the square root of 5? No, it's a prime number. So I square root of 5 would be my answer. Okay? So when you're simplifying, when you have a negative under the radical, the I comes out and it's written in front of the radical, not behind it. If you write it behind it, I'm going to take off points. Okay, it's written in front of it. So if I have the square root of -4, that's the same as the square root of -1 times the square root of 4, right? All I did was split that. Square root of -1 is I. What's the square root of 4? 2. All right. I'm not going to write I2. Would you write X2? No, you would write 2X, right? So you're going to write this as 2I. So your I is going to go behind the factor that comes out, but in front of the radical. Okay? So if I have the square root of -24, I have a negative. So I know what's going to come out. An I. So what I'm going to do is I'm going to take this 24 and I'm going to do my prime factorization for that. So 24 can split 2 and 12. 12 can split 2 and 6. 6 can split 2 and 3. You follow me? Okay. I have a pair of 2's. Now this 2 is left over and this 3 is left over. Okay. So I take out the 2 that I paired. And what else goes with the 2? I, because I had a negative. So 2I square root of. Now the 2 and the 3 I multiply together, and that's going to give me what? 6. You do not have to write 2 times 3 under the radical. Okay, y'all are in algebra 2. You should know you multiply that together and put it under the radical. Okay? Questions for that? All right. Do I understand that? Now, when I have -3 times the square root of -121, please hear me when I say you do not multiply negative times negative and all of a sudden become a positive. Okay? That is not at all what we're doing. Okay? What stays on the outside of the radical, what starts on the outside stays on the outside. Okay? So that's completely separate. So if I'm looking, I've got -3 that I'm going to bring down. And then I'm going to treat the square root of -121 completely separate. Okay? What is the square root of 121? 11. So I know I pull out 11, and what do I have to also pull out? That negative square root of a -1 leaves me with I. So I've got -3 times 11I. There's no radical because it's a perfect square. Okay? So if you have a perfect square, do not write a radical. All right? So -3 times 11I gives me -33I. And that's an answer. You cannot check your values with I. Okay. But you could take, the square root of a positive 24 and 2 square root of 6 and make sure that's the same value, but you can't type I in this calculator. You could with the Inspire, but not with this that we're going to use. Okay. 5 square root of -72. I want you to try to do this on your own, and then we're going to check to make sure y'all are on the right path. Okay, when you simplify 5 squared to negative 72, you bring down your 5. What does the square root of negative 72 simplify to? You'll get 6i square root of 2. Yes? Okay. So then my final answer, what do you get? 30i square root of 2. Okay, how do we do on that? Simple, but good? Okay, do I need to break down the 72 for some of y'all? Yeah, okay. So 72, if you divided it by 2, that gives you 2 and 36. 36 splits 2 and 18. I understand I could break this into other things, but if you leave it with 2s, it makes your tree a whole lot nicer and you don't miss certain numbers, okay? So then 18 is 2 and 9. 9 is 3 and 3. Okay. Now remember, if you don't know this off the top of your head, just take those numbers and keep dividing by 2. And it gives you those numbers I'm coming up with. Okay. So then you've got a pair of 2s, a pair of 3s, and a 2 left over. So it gives you the 5 that you started with, the 2 that you come up with, and the 3 you come up with, and then your I square root of 2. So there's your 5 times 2 times 3 to give you your 30. Okay? Does that make it better? Alright. So then now I've got negative 2 times the square root of negative 40. So if I take 40, I'm going to split that into 2 and 20. 20 splits 2 and 10. 10 splits 2 and 5. Okay. I have a pair of 2s with a 2 and a 5 left over. So I bring down the negative 2 that I started with, and I multiply that by what? 2i square root of 2 times 5 gives me 10. Okay, so my final answer should be, very good, negative 4i square root of 10. There are questions on that page? Okay. So, let's do operations in run first. Okay, we're going to look at adding, subtracting, and we're going to look at multiplying and then dividing. Okay, so if I add and subtract, okay, the index and the radicand have to be the same. So what does that mean? They've got to be the same radical and the same number underneath the radical. Okay, sometimes, majority of the time, you're going to have to simplify it first. Okay, if all I gave you was something like this, this is more so algebra 1. Okay, so here, square root of 3 plus square root of 3, are those radicals and the radicand the same? Yes, that's what makes it like terms, right? If I had an example like 2x plus 3y, could I make that anything to be one term? Can that simplify?
No.
No, that just becomes 2x plus 3y. But if I had 2x plus 3x, could I combine that? How come I can combine this but not this?
Same variable.
They have the same variable. That's what makes them like terms. So these radicals are going to make them like terms. Okay, so square root of 3 and square root of 3 can be combined. When you add them, you're only adding your coefficients. Okay, so you add or subtract the coefficients, but not the radicand. So what that means is the number underneath the radical, once you have it simplified, does not change. Okay, see how this 2x and 3x would give me a 5x, not a 5x squared. Just like square root of 3 plus square root of 3, my coefficients aren't written, but that's understood to be a 1. Anytime you don't have a coefficient written, put a 1 there so you don't get confused. Okay, so what I'm doing is I'm adding 1 plus 1 to give me 2, and then I leave square root of 3. Okay, now again, you can check the value of this. You can take square root of 3, get out of the radical by pressing the right arrow, and then square root of 3 again, well, plus square root of 3, you get this value. 2 square root of 3 gives me the same value. Okay, so for those of you who want to check, that's how you can check. Okay, so here I've got 7 square root of 5 minus 12 square root of 5. Are those like terms?
Yeah.
Yeah, because I have square root of 5 square root of 5. So I'm going to look at my coefficients. 7 minus 12. What does that give me? Negative 5, and I leave square root of 5. Okay. Now, square root of 12 plus square root of 75 are not like terms. Okay, but what I need to do is I need to simplify them. Okay, so I'm going to take a 12, and I'm going to break that apart. So that splits into 2 and 6. 6 splits 2 and 3. Okay, so I have a pair of 2's with a 3 left over. So the square root of 12 can simplify to 2 square root of 3. Yes? Y'all follow me? And then I've got square root of 75. So I'm going to take 75 and I'm going to split that. Now that's not an even number. So I'm not going to split that in 2. What can I split it into? I could do 5 or I could do 3. Okay, if I do 5, what does that split into? 5 and 15. And then 15 can split into 3 and 5. Alright. Now if I write it like this, hopefully you still see I've got a 5 and a 5 there. So I've got a pair of 5's. And I have a 3 left over. Okay, so square root of 75 simplifies to 5 square root of 3. Now are they like terms? Yeah. 2 plus 5 gives me 7 square root of 3. And this would be where I would really check my work. I would check square root of 12, get out of the radical, plus square root of 75. And then 7 square root of 3. I would take that extra few seconds, check your work. Okay?
Okay.
Your grade will thank you. Okay? Alright, 3 square root of 2 plus square root of 18. Not like terms. Can I simplify the square root of 2? No. Can I simplify square root of 18?
Yeah.
Yeah. So I'm going to take 18 and I'm going to split it. 2 and 9. 9 splits. 3 and 3. So I've got a pair of 3's with a 2 left over. So I have 3 square root of 2 plus, what am I going to write? 3 square root of 2 again. Okay? Now, what's my final answer going to be? 6 square root of 2. 3 plus 3 gives me 6. And I leave the square root of 2. Okay? Alright, now I've got 2 square root of 8 plus 5 square root of 2 minus 4 square root of 3. So I'm going to start one by one. Okay? Square root of 8, can I simplify that?
Yeah.
So I take my 8. That splits 2 and 4. 4 splits 2 and 2. I have a pair of 2's with a 2 left over. Now I already have a 2 out here. So what is 2 square root of 8 really going to simplify to?
4
square root of 2. Very good. And then I leave my plus 5 square root of 2 minus 4 square root of 3 because those are already simplified for me. Okay. Now, are they all like terms?
No.
No. My only 2 like terms are what? These 2. All right. So I can add these 2 and that becomes what? 9 square root of 2, and I leave the minus 4 square root of 3. Sometimes there's nothing you can do with that. If it's not a like term, it just makes it put. And again, you could add all of this in your calculator, type your answer, get the same value, you're good. Okay? There are questions on that? All right. When we multiply, okay, your index has to be the same. So again, that's not a problem right now because we're just doing square root. Okay? They're already the same. The number underneath the radical can absolutely be different. Okay? What you're going to do is multiply your, I'm going to write it because I don't think I have it. You're going to multiply coefficient times coefficient. And then radical times radical. Okay, so I'm gonna take two terms. If I have coefficients, I multiply those. And then radical times radical means, technically I should say radicand times radicand, but it's easier to just write this out. The radical times radical means you multiply what's under the radical. Okay, so its corresponding term is what you multiply. Okay, so if you want, you can simplify first, then multiply and check to simplify again, or you can just multiply, get large numbers, and then simplify once. Okay, the key is always simplify. Don't ever leave it unsimplified. You're gonna lose credit. Okay, so if I have square root of 3 times square root of 15, neither one of those I can simplify. Okay, so I don't have coefficients to multiply, so I'm just going to multiply what's underneath the radical. So square root of 3 times square root of 15 is going to leave me with square root of, what's 3 times 15? 45. Then I simplify 45. Okay, 45 can split into 5 and 9. 9 splits 3 and 3. So it leaves me with 3 with a 5 left over. So 3 square root of 5. And again, type this in your calculator, get a value, type your answer, get a value, make sure they match. Okay? Now, when I have 3 square root of 7 squared, what does squaring something mean? I multiply by itself. So you can either distribute that squared to the 3 into the square root of 7, and I'll recommend that in your first step. Okay? What I would do is write 3 square root of 7 times 3 square root of 7 until you get the hang of what it does to square it. Okay? So squaring it means multiplying it by itself. So then here I've got coefficient times coefficient. So 3 times 3 gives me 9. Square root of 7 times square root of 7 gives me the square root of 49. Okay? What do I know about the square root of 49? It's just 7. So this is 9 times, is it the square root of 7 or just 7?
7.
It's just 7. It's a perfect square. I do not write the radical. Okay, well, what's 9 times 7?
49.
63. Okay, so if you get the hang of it, you can distribute that squared. Okay, so I could have done 3 squared times the square root of 7 squared. 3 squared is 9. Square root of 7 squared is square root of 49, which leads me to all the same stuff. Okay, I don't recommend this to everyone because that can confuse you. Okay, I'd rather you write it twice and go through the process. All right. Now, what about if I have 2 minus square root of 5 squared? Okay. If I have in parentheses 2 minus square root of 5 squared, what am I actually multiplying by itself? Is it just the square root of 5 or is it the whole thing? You have to be careful, it's the whole thing. So I'm going to write 2 minus square root of 5 times itself 2 minus square root of 5. Okay. Now I want to compare that to if I had 2 minus x times 2 minus x. If I gave you this and told you to simplify, what would you do? Y'all remember what it's called? FOIL. Okay. I would FOIL that and multiply all 4 things, right? Y'all remember that? We're going to FOIL this. Okay, so you take your first term, and you're going to multiply it by each term in the second set of parentheses. So 2 times 2 gives me 4. When I take a coefficient, a whole number, and I multiply it by a radical. So think about if I have 2 times x, what would that give me? 2x. So if I have 2 times square root of 5, that would give me 2 square root of 5. Y'all see the similarity there? Okay, so that's what's happening here. I've got 2 times negative square root of 5. So positive times negative is a negative, and then 2 square root of 5. okay? When you have to FOIL, take your time so you don't make mistakes, okay? So now I take negative square root of 5 times 2, which again, positive times negative gives me a negative. Whole number times radical, you just mush them together. 2 square root of 5. Y'all follow me on that? Okay. And then negative square root of 5 times negative square root of 5. Negative times negative is a positive. Square root of 5 times square root of 5 gives me what?
5,
5. How do I know that?
just multiplying it by itself. The opposite.
So as you work it, if you catch the square root of anything times itself is really just a number under the radical, you can do that, okay? But for right now, if you need to say square root of 25, then that's fine too, okay? But we know the square root of 25 simplifies to 5. Okay, so now I need to simplify it. I take my like terms, 4 plus 5, and that gives me 9. And then I've got negative 2 square root of 5 minus 2 square root of 5. Those are like terms. So I do my coefficients. Negative 2 minus 2 is negative 4 square root of 5. Okay, so you multiply your first step, and then you combine by adding and subtracting for the second step. Okay, you understand that? Okay. All right. Now, what if I have something like this? I have square root of 3 times 2 square root of 2 plus 4 square root of 6. Okay, you have to be careful with this number, this lesson when you start multiplying, because it can get messy. Okay, so do little by little. So if I had just a 3 times 2x plus 4y, what would I do with this? I would distribute. I always go back to x and y with your variables because y'all are used to seeing that. Okay, I would distribute this. So I'm going to take the square root of 3 and I'm going to distribute it to both terms. Now remember, when you multiply, you only multiply its like corresponding part. So if I have square root of 3 times 2 square root of 2, does this coefficient 2 change? No. So I've got 2, and then square root of 3 times 2 gives me 6. Plus, square root of 3 times square root of 6, does the 4 change?
No.
No, there's nothing on the outside multiplying by it. But I do square root of 3 times square root of 6, which is square root of 18. Now I check to simplify. Can I add 2 square root of 6 and 4 square root of 18?
No.
No. What do I need to do? Which one do I simplify? 18. 6 can't. It's a 2 and a 3. I can't do anything with that. Okay. So 18 splits 2 and 9. 3 and 3. So I have a 3. Pair of 3 with the 2 left over. Okay. So I bring down my 2 square root of 6. Plus, I'm taking out a 3, but I already have a 4. I multiply those and that becomes 12 square root of the 2 that's left over. Now can I add that?
No.
No, that's okay. You've got it down to simplified terms. That's my answer. If I'm unsure of myself, what do I do?
Add them together.
Yeah. You type this in your calculator. Type this in your calculator. Make sure it gives you some. Okay? Questions? Is it okay? I know it's not the most exciting one, but this is really important for the whole entire rest of this part of chapter 4. Okay? All right. 3 square root of 15 times 6 square root of 18. You can do one of two things. You can simplify square root of 18, or just multiply, simplify it once. Okay. It's up to you if you want to work with large numbers or work with smaller numbers. Okay. I personally like to simplify first. Okay. You don't have to, but that's what I do. Okay. So that's what we're going to do. 3 square root of 15. 15 is just 5 times 3. I can't do anything. So I can't simplify 3 square root of 15. Okay. Now 18 we've already done. I'm not going to write it again. Okay. 18 we just did. That simplifies to 3 square root of 2, but I have a 6. So 3 times 6 would leave me with 18 square root of 2. Y'all see how I simplified that? Okay. Now I can multiply. What's 3 times 18? 54. And then square root of 15, square root of 2 gives me square root of 30. Now, can I leave it like that?
No.
If I typed it in my calculator, it would give me the same value, but it's not simplified. Okay, so I need to simplify 30. So that leaves me with 2 and 15, 3 and 5. It looks like it should be simplified, but can it?
No.
No. 2 cannot pair, 3 cannot pair, 5 cannot pair. So even though that's a large number, that is simplest form. Are we good? All right, this one is big. Okay, so we need, bless you. We need to make sure we're writing neatly and that we're paying attention to what we're doing. Okay. Now, the FOIL process that we did up here is the exact same here. We just now have coefficients. Do you want to try this on your own? Or do you want me to do it? Can you do it? So if I multiply 3 square root of 6 times 2 square root of 2, I'm going to do coefficient times coefficient, its corresponding part. So 3 times 2 gives me what? 6. Square root of, okay? Now I'm only looking at this. If you need to cover it up, cover it up, okay? Square root of 6 times square root of 2 is what?
12.
Square root of 12. Plus, I take 3 square root of 6 and multiply it by the square root of 3, okay? So if all I'm looking at is here, does the coefficient 3 get changed?
No.
No, so it stays 3. Square root of square root of 6 times square root of 3 is 18. Okay, halfway there. Do we understand that? Alright. So 4 square root of 7 times 2 square root of 2. Okay, I'm covering up what I don't care about. Alright, so 4 gets multiplied by the outside 2, and that gives me 8. And then I multiply the two radicals, square root of 7 and square root of 2 gives me 14. Okay, and then my last one, 4 square root of 7 times square root of 3. So again, I'm covering up what I don't need. Does the 4 get multiplied by anything? No, because it's just a 1. So I've got 4 square root of what? 21. Now, if you are someone who struggles with that, okay, if you're looking at that and you have no clue or you're kind of unsure, I would take 2 highlighters and I would highlight all my coefficients one color, and then I would highlight my radicals another color. And if I separate them by color and I'm looking when I multiply, I can only multiply color by color. Does that make sense? So that 3 doesn't get multiplied by that 2 that's under the radical. It only gets multiplied by the 2 that I highlighted blue. So if you are visual, that can help you. Okay, and you could do that the whole time if you needed to. If you needed to do 3 and 6, and then you multiply that, and then do your radical. Okay, just a tip if you're struggling with what I'm doing. Okay, all right, now I'm going to try to combine like terms, but I have a 12, an 18, a 14, and a 21. All of those are different. Okay, so if I can't do it, then I'm going to simplify. All right, I can simplify 12, I can simplify 18. 14 will not simplify because that's 2 and 7. 21 will not simplify because it's 3 and 7. There's no pairs to make. Okay, so 12 will simplify 2 and 6, and then 2 and 3. So I take my pair of 2 and the 3 left over. Now this pair of 2, I'm going to multiply by the 6, and that becomes what? 12 square root of 3. plus 18. Again, I'm gonna go back to what I already wrote. I'm not gonna do it again. Okay. 18 simplifies to a pair of 3 with a 2 left over. Okay, so I take the pair of 3 and multiply it by the coefficient 3. 3 times 3 gives me 9 square root of 2 plus 8 square root of 14 plus 4 square root of 21. Again, 14 and 21, I won't be able to make pairs, so I'm not going to simplify. Can I add anything now?
No.
No. So even though it looks weird, that's my simplified answer. And again, type it in your calculator check. Okay? Do you have questions? All right. The last section, we're dividing. This is going to take you to rationalize, but I know that y'all did rationalization in geometry when you did special right triangles, right? When you did 45, 45, 90, 30, 60, 90, you should have. Okay. So our quotient property just tells us if you have the square root of a over b, one fraction, you can split those into two separate radicals, square root of a over square root of b. Okay. We're going to utilize that frequently, every problem. Okay. So the problem that we run into is that you cannot have a radical in the denominator of a fraction. Okay, so we rationalize. So what that means is you're going to simplify as much as you can step 1. Okay, so I'm going to look at, are they perfect squares? I'm going to look at, can the fraction simplify so I have smaller numbers? And then I'm going to move on to rationalizing. Okay, rationalizing means you're going to multiply the numerator and the denominator by the same radical that you want to get rid of. Okay, now the reason we do that is because if you think back to our example, I could automatically jump to what answer?
20.
20. Y'all follow me? Yes, no. We're gonna do it again. If I have the square root of 3 times square root of 3, that will jump to
3.
3. Because it's square root of 9, which is 3. Okay, so anything times itself under the radical, you're left with a number under the radical. Okay, so that's the key to rationalizing. All right, so always simplify beginning and end. Okay, so if I have the square root of 9 over 25, I can split that square root of 9 over square root of 25. What is the square root of 9?
3.
3. What's the square root of 25?
5.
I didn't have to rationalize there if I checked for perfect squares. Okay? Now, if I have square root of 75 over 8, I'm going to see, I'm going to show you how to check to simplify a fraction in here. Okay? If you have a fraction, type your fraction in your fraction bar button, 75 over 8. If it can simplify, it will simplify here. If it can't, it won't. So I can't simplify this as fraction-wise goes. But if I split it, square root of 75 over square root of 8, I can simplify that. Okay? I want you to try to simplify those two separately. Okay, what is the square root of 75 simplify to?
5 squared root of 3.
5 square root of 3. And square root of 8 simplifies to
2 squared root of
2 square root of 2. Okay. You should be able to do that. Okay, those of you who are sleeping, you need to wake up. Now, our one rule is that you can't have a radical in the denominator. Okay, so is the 2 coefficient wrong? No. Only the radical is wrong. So we're not going to multiply by the full 2 square root of 2. We're only going to multiply by square root of 2. And what do I do to the bottom? I have to do to the numerator as well. Okay, so you're only changing the radical. You're multiplying it by itself. If this were a 5, I would multiply it by square root of 5. Okay, so then what I'm going to do is I'm going to multiply numerator times numerator and denominator times denominator. Okay, so 5 square root of 3 times square root of 2. The 5 stays because I have nothing to multiply it by. There's not another coefficient other than 1. Square root of 3 times square root of 2 gives me square root of 6. Okay, now my denominator, this 2 that I already had, okay, I already had it, it comes down. And then square root of 2 times square root of 2 ultimately gives me 2. Okay, now I simplify that. 5 square root of 6 over 4. Once I get it down to here, I check, can I simplify the radical? No, it's just 2 and 3. Can I simplify 5 divided by 4?
No.
No. So this is my final answer. Okay. You understand that? I know I'm taking my time on it, but this is important. People struggle with this lesson. Okay. So here, my next example, 2 squared root of 6 over 5 squared root of 10. Okay, I'm going to check, are these perfect squares, 6 and 10? No. So then I check, can I simplify 2 over 5? No. Can I simplify 6 over 10? Yeah, 6 over 10 will simplify. If you don't know, use the trick that I just showed you in your calculator. Type your fraction, 6 over 10. As long as your mode is correct, it will simplify it to 3/5. Okay, so that simplifies to 3/5. So what I'm doing is I now have 2 square root of 3 over 5 square root of 5. All I did was simplify the 6 over 10 to become 3 over 5. Y'all follow me? You don't have to do that. I like to simplify for smaller numbers first. Okay. Now, what am I going to multiply by? Just the square root of 5. Okay. So 2 square root of 3 times square root of 5 is going to give me what as my numerator? 2 square root of 15. I bring down the 5 that I already have, and then I multiply that. Square root of 5 times square root of 5 is 5. So this is 2 square root of 15 over 25. Then I check, can I simplify square root of 15? No. Can I simplify 2 over 25? No. Even though it looks like I should simplify 15 and 25, I cannot. If it's under the radical, that's separate. Okay? So this 2 square root of 15 over 25 would be my answer. Okay? Are we okay? Are there questions? All right. This is a big lesson. There's a lot to it. All right. So now I take it a step further. Okay. These are the problems I added just to make sure you understood it for the worksheet. 3 minus 2 square root of 2 over 4 square root of 3. I cannot simplify this. So what's the only thing wrong with this? This radical in the denominator. Square root of 3. All right. So I'm going to multiply the numerator and the denominator by the square root of 3. Now, when I do the numerator, if you need to write it again, you can, but I'm just gonna work on my problem, okay? I'm taking the square root of 3. I have a binomial, which is 2 terms. I'm gonna distribute square root of 3 to the 3 and to the negative 2 square root of 2. I multiply it by both terms, okay? So 3 times the square root of 3, I have a whole number times a radical, I just mush it together, 3 square root of 3. And then I take negative 2 square root of 2 times square root of 3. Does the outside 2 change?
No.
No, so it's negative 2 square root of 6. Over the 4 that I started with comes down, and I'm multiplying that by what?
3.
3. Y'all okay with that? Okay. Now I simplify. Can I simplify square root of 3?
No.
Can I simplify square root of 6?
No.
Can I add them together? No. So 3 square root of 3 minus 2 square root of 6 stays in the numerator. And then 4 times 3 is 12. Now that I've got to this point, I just check my coefficients. Can 3, 2, and 12 all simplify and be divided by the same number? No. If this was a 4, 2, and 12 could all be reduced. But a 3, 2, and 12 cannot. Okay, so this is my final answer. Okay, sometimes you can simplify, sometimes you cannot. All right, last one. Do you want to try this one on your own? Let's try it. Okay, I want you to try it, then we're going to go over it. Okay, y'all all got that we're supposed to multiply by what? Square root of 5. Okay, so when I distribute that, 10 times the square root of 5 is 10 square root of 5, plus 5 square root of 2 times square root of 5 is 5 square root of 10. And then 6 times 5 in my denominator. Okay? So that leaves me with 10 square root of 5 plus 5 square root of 10 over 30. Okay? Now, I can simplify this. Okay? Some of y'all stopped there, some of y'all went further. Okay? What can I simplify for this? The 10, the 5, and the 30. I can divide all those by 5, and that leaves me with 2 square root of 5 plus square root of 10 over 6. Okay? Questions on that? All good?
Couldn't you divide the one before this one by two, like all the.
No, because of the 5 right here.
Left of that. This thing.
Oh, this one?
Yeah.
I could not because of 30.
Oh.
So they all three have to be divisible by the same number.
Alright.
Okay? Okay, any other questions? Okay? We're not done. We still have conjugates. That was rationalizing. Okay? So conjugates is rationalizing when you have a binomial in the denominator. Okay? So what that means is if I have two terms being added in my denominator and it includes a radical, I'm going to have to rationalize by a conjugate. Okay? So the conjugate is if I have a plus square root of b, its conjugate is the exact same thing, but a different sign in the middle. Notice that the a did not change. Only the sign in the middle did. Okay? And so if I have a minus square root of b, its conjugate is a plus square root of b. So the same exact thing, same exact terms, but change the sign in the middle. Okay? All right, I'm going to give you an example of something. If I have x plus 2 times x minus 2, and I FOILed that. If I FOILed the whole thing, x times x would give me x squared, x times negative 2 is negative 2x, 2 times x is a positive 2x, and 2 times negative 2 is a negative 4. Okay? If I gave you this example and I told you, okay, you have to simplify, what happens to these middle terms?
They cancel each other.
They cancel each other out, leaving me with x squared minus 4. Okay? X plus 2 and x minus 2 were conjugates. Even though I didn't have a radical, those are conjugates, and those are the difference of two squares. This goes back to quadratics in algebra 1. Okay? And it leads me to x squared minus 4. So my formula for conjugates tells me, okay, if I have a plus b times a minus b, my shortcut is just taking my first term, squaring it, minus second term, squaring it. Okay, so does that apply here? Well, yeah. I had x times x, so I take x and square it, minus 2 and square it. That gives me my x squared minus 4. Okay, so instead of FOILing every single problem for the denominator, we're going to use this shortcut. Okay, now pay attention that it is always a minus in the middle. Always, no matter what. Okay? Because of the sense that you are going to have a positive times a negative when you write it out. Okay? So if I have a plus the square root of b times a minus the square root of b, so what we're looking at in this lesson, you're going to take your first term, square it, minus the square root and square it, which is always going to end up giving you the number under the radical, right? Square root of 2 times square root of 2 is 2. Okay? So this is only if you have a constant, a whole number, with a radical being added in the added or subtracted in the denominator. Okay. So if I have 3 over 7, if it's hard to tell, it's 7 plus square root of 2. Okay. I have 2 terms being added. I still cannot have a radical. So this is when I use the conjugate. So the difference between here and what we just did is I have a plus or minus between the two. Okay. So my conjugate, if I start with 7 plus square root of 2, my conjugate is 7 minus square root of 2. If you don't change that sign in the middle, it's not its conjugate. You're doing it wrong. It is wrong. Okay. So here, my numerator, I'm still going to distribute this 3 to each term. Okay, so 3 times 7 is 21. 3 times negative square root of 2 is a negative 3 square root of 2. Okay, now my bottom, it's conjugates, I'm going to use my formula. My formula tells me I take my first term, which is 7, and square it, minus my second term, which is square root of 2, and square it. And I want to see you write that, because that's going to help me give you partial credit. All right, 21 minus 3 square root of 2, I can't do anything with. 7 squared is what?
49.
49. Minus square root of 2 squared is just 2. Right? Because that's just square root of 2 times square root of 2, which is just 2. Alright, so I've got 21 minus 3 square root of 2. 49 minus 2 is
47.
47. Can I simplify that? No. Okay. So now I'm going to look at square root of 6 over 4 minus square root of 2. Okay. I need to rationalize it by its conjugate. What is its conjugate?
4.
Same thing, just change the sign. Very good. So when I distribute this, square root of 6 times 4 is what? And then square root of 6 times square root of 2 is square root of 12. All right, my denominator, my formula tells me I take my first term, which is 4, and I square it, minus second term, which is square root of 2, and I square it. Okay, can I simplify 4 square root of 6? No. Can I simplify square root of 12?
Yeah.
Yeah. 12 splits 2 and 6. 6 splits 2 and 3. I have a pair of 2's with the 3 left over. So that simplifies to 2 square root of 3. Now my denominator, 4 squared, is 16, minus square root of 2 squared is
2.
2. So I've got 4 square root of 6 plus 2 square root of 3 over 14. Can I simplify that? Yeah, my 4, my 2, and my 14 can all be divided by what?
2.
2. So that leaves me with 2 square root of 6 plus square root of 3 over 7. Y'all understand what the conjugate? Okay. All right. I want you to try the next one on your own. Okay, so y'all can all multiply by the conjugate, but what I'm seeing right now is a lot of y'all are getting stuck at what to do once you multiply, okay? Or how to multiply, okay? So we know my conjugate is what? So I write that and I multiply top and bottom by 2 minus 4 to 5. Okay, I have 2 terms and 2 terms. So I FOIL that. Okay, so I'm going to take 7. 7 times 2 is 14. 7 times negative square root of 5 is negative 7 square root of 5. Then negative 2 square root of 5 times 2 is a negative 4 square root of 5. Then negative 2 square root of 5 times negative square root of 5 is a positive. What happens here?
It's like 25.
2 square root of 25, or 2 times 5. Right? Because square root of 5 gives me 5. If you wrote square root of 25, that's okay too. Okay, you'll simplify it then. Then my denominator, which I noticed some people were good on the denominator because you know your formula. You take the first number, which is 2, square it, minus square root of 5 squared. So to clean it all up, 2 times 5 gives me 10. 14 plus 10 is 24. Then negative 7 square root of 5 minus 4 square root of 5 gives me negative 11 square root of 5. Very good. And then my denominator, 2 squared is 4 minus square root of 5 squared is 5. Okay, so 24 minus 11 square root of 5. 4 minus 5 is negative 1. Can I leave it like that? No, we're not going to leave a negative in the denominator regardless of what the number is, okay? Now, it's a 1, so I can easily divide these by -1, and all it does is give me,
One.
okay, so do I need a denominator?
No.
No, it was a 1, okay? I don't need to write over a positive 1. This is my final answer. Okay? That's a lot. That's a lot of steps. That's a lot to have room for mistakes. Okay? Take it little by little. Okay? The good news is you're not going to have too many of these. Okay? That's not what your whole lesson is comprised of. Okay? The first 3 sections were very easy. Okay? One last one, and then y'all have made it through. Okay? I have 1 plus square root of 6 over 5 minus 4 square root of 3. Okay? So what is my conjugate?
5 plus 4.
Very good. Can y'all all recognize that? Okay. All right. Now my numerator, I'm going to FOIL again. 1 times 5 is 5. 1 times 4 square root of 3 is just 4 square root of 3. Square root of 6 times 5 is going to give me what?
5.
5 square root of 6. And then square root of 6 times 4 square root of 3 is going to give me what?
4.
4 square root of 18. Very good. Okay. My denominator. I take my first term, which is 5, and I square it. Minus, what's my second term? 4 square root of 3, and I square it. Okay, notice that when I'm doing this formula, I'm not including a sign here because I'm squaring it. Okay? Now, I got a lot going on here. What do I need to do with my numerator? Do I have like terms? That's what I would check for first. I don't have like terms, but I need to do what? Simplify
4.
4 squared 18. Okay, so 18, it's not on the same page, so I'm going to do it. 2, 9, 3, 3. I have a pair of 3s with a 2 left over. So I'm going to copy the 5 plus 4 square root of 3 plus 5 square root of 6. 4 square root of 18 is going to turn into what? 12 square root of 2. Very good. Okay, the 5 squared is going to turn into 25 minus. When you take 4 square root of 3 and you square it, you have to be careful. If I were y'all, I would write 4 square root of 3 times 4 square root of 3. Because most common mistake, like 98% of my kids every year, forget to square the 4 also. Okay, so 4 times 4 is 16, and then square root of 3 times square root of 3 is 3. What's 16 times 3?
48.
48. You understand that? No questions on that? Okay, so now we just need to simplify the denominator. So 5 plus 4 square root of 3 plus 5 square root of 6 plus 12 square root of 2. And what's 25 minus 48?
-23.
Negative 23. Can I simplify this?
No.
Number wise, no. But if I left it like this, I'm going to get a point off. What's wrong with it? The negative in the denominator. So all I'm going to do is change all the signs because I can divide by -1. Okay, I can divide everything by -1 to make that denominator a positive 23. So all that does is make it a negative 5 minus 4 square root of 3 minus 5 square root of 6 minus 12 square root of 2. Okay? Do you have questions on the steps? Okay, this is important to understand because if you can't get this down, you will not be able to do 4.1. Okay, which we're doing all this, but with imaginary numbers. Okay, so we don't have a quiz over this lesson specifically, but you have to be able to do this to do the next one. Okay.